So, today we will be continuing the lesson magnetic effects of electric current, and in that we will be studying about magnetic field due to current through circular loop and also magnetic field due to solenoid. So, this is part number 4 of the lesson. In the last session we had studied about magnetic field due to current carrying conductor. In that we had also studied about magnetic field due to current through straight conductor. Then we had studied about right hand thumb rule also. And today we are going to start with magnetic field due to current through circular loop. Now, suppose there is a straight wire which is bent in the form of circular loop like this, and current is passed through it. What will happen? We know that magnetic field produced by current carrying straight wire depends inversely on the distance from it, right? So, similarly, at every point of current carrying circular loop, the concentric circles representing the magnetic field around it would become larger and larger as we move away from the wire, as you can see from here. So, these circles are becoming larger and larger. So, the radius is increasing, and so ultimately when it will reach in between, it will be a straight line, right? So by the time we reach at the center of the circular loop, the arc of these bigger circles would appear as a straight line. So this one that I showed you is a straight line. Every point on the wire carrying current would give rise to magnetic field appearing as a straight line at the center of the loop. So it will be a straight line. By applying right hand thumb rule, it is easy to check that every section of the wire contributes to the magnetic field lines in the same direction within the loop. So we can use this right hand thumb rule that we had studied in the earlier session in this case. Now, we know that magnetic field produced by current carrying wire at a given point depends directly on the current passing through it. So if this is a circuit which is a source of current for this loop, then magnetic field produced by current carrying wire at a given point will depend on the current passing through it. So if I change the current, it will affect the magnetic field also. Therefore, if there is a circular coil having n number of turns, the field produced is n times as large as that produced by a single turn. तो अगर मैंने नंबर ऑफ टर्न्स बढ़ा दिए यहाँ पे, तो मैग्नेटिक फील्ड भी उतनी टाइम्स बढ़ेगा. अगर n टर्न से बढ़ा है तो n टाइम्स मैग्नेटिक फील्ड बढ़ेगा. And why do we find such case? Because the current in circular turn has the same direction and the field due to each turn then just adds up. तो करंट जो होता है वो हर सर्कुलर टर्न के लिए एक ही डायरेक्शन में होता है. ओके एंड हर जैसे हम टर्न बढ़ाते जाएंगे तो फील्ड उसमें ऐड होते जाएगा, तो फील्ड भी बढ़ते जाता है. ठीक है बच्चों. सो दैट वाज मैग्नेटिक फील्ड ड्यू टू करंट थ्रू सर्कुलर लूप. देन द फील्ड इनसाइड द सोलेनॉइड आर इन द फॉर्म ऑफ पैरेलल स्ट्रेट लाइन. तो सोलेनॉइड के अंदर का जो मैग्नेटिक फील्ड होता है, it is a straight line, and though these are parallel straight line, they do not intersect each other. In fact, magnetic field lines never intersect each other. Within the magnet it is a parallel straight line, whereas outside they are circular loops. Then the field inside the solenoid are in the form of parallel straight line. तो solenoid के अंदर का जो magnetic field होता है, it is a straight line, and though these are parallel straight line, they do not intersect each other. In fact, magnetic field lines never intersect each other. Within the magnet, it is a parallel straight line, whereas outside they are circular loops. So coming to the next point, this indicates that the magnetic field is the same at all the point inside the solenoid. सभी जगह पे सेम रहता है मैग्नेटिक फील्ड, कहाँ पे? सोलेनॉइड के अंदर, क्योंकि पैरेलल मैग्नेटिक फील्ड है, एंड दैट इज द फील्ड इज यूनिफॉर्म इनसाइड द सोलेनॉइड, तो सेम है. A strong magnetic field produced inside a solenoid can be used to magnetize a piece of magnetic material like soft iron when placed inside a coil. तो कॉइल के अंदर अगर हम सॉफ्ट आयन रखेंगे तो हम उसे मैग्नेटाइज कर पाएंगे. So a strong magnetic field produced inside a solenoid can be used to magnetize a piece of magnetic material. तो मैग्नेटिक मटेरियल होना चाहिए, जैसे कि आयन है, सॉफ्ट आयन, तो वो अगर अंदर हम रखेंगे कॉइल के अंदर तो उसे हम मैग्नेटिक कर पाएंगे, मैग्नेटाइज कर पाएंगे. सो दैट वाज रिगार्डिंग मैग्नेटिक field inside the solenoid. So what do we call such type of magnets? Such type of magnet which is produced temporarily because of electric current is called electromagnet. So that was all for today. Now it's time for some assignment. Assignment questions are these questions. Remember, they are from your textbook. After these topics you will find them in textbook also. So I purposely took that questions so that you become well aware of their answers also. Well, the questions are: consider a circular loop of wire lying in a plane of the table. Let the current pass through the loop clockwise. Okay, so current को हमें pass कर देना है clockwise. Apply the right hand thumb rule to find out the direction of magnetic field inside and outside the loop. तो हमें magnetic field का direction बताना है inside the loop and outside the loop also. Second question is magnetic field in a given region is uniform. एक रीजन है जहां पे मैग्नेटिक फील्ड यूनिफॉर्म है. यू हैव टू ड्रॉ अ डायग्राम टू रिप्रेजेंट इट. उसका डायग्राम निकालना है. ओके, नाउ इन सोलेनॉइड ओनली वी स्टडीड दैट सिंस मैग्नेटिक फील्ड लाइंस आर पैरेलल देयर मैग्नेटिक फील्ड इज यूनिफॉर्म. तो अगर यूनिफॉर्म है तो मैग्नेटिक फील्ड कैसे रहेगा? स्ट्रेट पैरेलल लाइंस रहेंगे. आप हॉरिजॉन्टल दिखा सकते हो या पैरेलल दिखा या वर्टिकल दिखा सकते हो, but it should be parallel. Then third question is choose the correct option. Magnetic field inside a long straight solenoid carrying current is 0, decreases as we move towards its end, increases as we move towards its end, is same at all the points. तो ये चार options हैं. Remember that this is regarding magnetic field inside a long straight solenoid carrying current. सोलेनॉइड के अंदर का करंट के बारे में पूछ रहे हैं, तो ये उसके ऑप्शंस हैं. ओके, सो यू हैव टू सिलेक्ट फ्रॉम दिस. वेल, दैट वाज असाइनमेंट फॉर द डे. आई होप you enjoyed the session. If you have any doubt, feel free to ask. See you in next session. Until then, take care. Bye bye.